Okay, we're going to talk about 8.2, the use properties of parallelograms. Right here on the right side of your screen, you should see the opposites, 6 properties of the parallelograms that you'll need to go ahead and memorize. And those 6 properties will help you solve parallelograms when you're dealing with them. And it makes this section very easy, so this will be a short video, so stick with it. Alright, so when you're dealing with the parallelograms, the first property is you have opposite sides are parallel. So right here you can see that CB is parallel to DA, as well as AB being parallel to CD. Okay, so you have two pairs of sides that are both parallel to one another. This will help us when we're looking for angle measures here in just a second. But you also have opposite sides are congruent. So you know now that CD, and I'll write this down so you have it, but CD is congruent to BA, and DA is congruent to CB. Since we have parallel lines, we have consecutive angles, and those consecutive angles are going to be supplementary. If you remember, if CB and DA are parallel, that means you have CD, this line right here, CD, being a transversal, which creates these lines, or these angles being supplementary. Okay, and if you remember the definition of supplementary, meaning that angle C and angle D are equal to 180 degrees. Again, that's going to help you solve parallelograms when necessary. Okay, with that, we also understand that opposite angles, okay, are congruent. So watch this here. If I take a diagonal, we'll use purple. Okay, if I take a diagonal and I cut my parallelogram like that, what do you see now? You'll see that these angles are alternate interior angles. Because remember, you have created a new transversal now, and DA and CB are still parallel. Now you have a new transversal, that diagonal, that creates alternate interior angles. So that's why they're going to be congruent. And since these are going to be supplementary or complementary or whatever you want to call it to each other, you know that they're having corresponding parts will allow those two those two giant angles, those big angles. So let me go back. So these big angles right here will be congruent. Okay? And that means vice versa with D and B. D and B will also be congruent. Now if I put 2 diagonals in here, so one here and one here, okay, I know the diagonals bisect each other. Okay, so that means that this side is congruent to this side, as well as this side being congruent to this side. So I'm getting a lot of information on my parallelograms. And then finally, you have one pair of sides, both parallel and congruent. Okay, and that's just restating what we've already talked about at the beginning. So that's your 6 properties of parallelograms. So if we throw some numbers in here, if we know that CD is equal to 8, what does that make BA? Well, if both sides are parallel, if a pair of sides are both parallel and congruent, that means BA is not only parallel to CD, but it also is congruent to CD, making BA 8 centimeters or 8 as well. Okay, let's go ahead and take a look at a couple of examples that are pretty simple that you'll be working on in your homework. Okay, so if I want to solve this for x, given x plus 4, okay, I know that x plus 4, because I know the properties of a parallelogram now, that x plus 4 is going to be congruent to 12 because parallelograms have both congruent and parallel sides, two pairs of them. All I have to do now is solve for x, and x is simply 8. No problem. And then if I want to find the measure of this angle here, where it's y degrees, I know, because again, the properties of my parallelogram, that y is congruent to 65, therefore y, the measure of angle y, is equal to 65 degrees. So really not a lot of work there. Not involved at all, as long as you know the properties of a parallelogram. Okay, so let's find out more. You probably have to have more in depth than that. You want to get more work than that. So let's look at this example here. On this example, we want to find Km, this is the length of Km, the length of Nm, angle measures KML, MKL, and angle measures KLM and JKL. Okay, so we're given some information, which you see on the diagram there. So using that information, that should help us solve the rest of this. Okay, so looking at Km, if you look right here, this is Km. Okay, what is the length of Km? Well, if you know that Kn is 2, and if you remember the properties of a parallelogram, the diagonals bisect each other, so that means that Nm is 2, and since Kn plus Nm, the segment addition postulate will tell us that Km is equal to 4. Okay, we already figured out Nm in order to figure out Km, so Nm is 2. Now we need to look at angle KML. On angle KML, okay, we see that, first of all, we see that this angle here, let's look down here on our given, KJM, which is this angle here, we know is 110 degrees. So that goes right there. If that's 110 degrees, that means this angle right here has to be 70 degrees because they are supplementary. They're consecutive interior angles. Since they are consecutive interior angles, they are supplementary, meaning they equal 180. So if angle JML is equal to 70 degrees and I have KMJ equaling 30 degrees, that means this angle right here, which is KML, has to equal 40 degrees. Okay, MKL. MKL is going to be equal to 30 degrees. And again, knowing our properties of a parallelogram, they are alternate interior angles because you have your diagonal being a transversal of line LM and line KJ. All right? And then KLM, okay, that's this angle up here, the big angle. KLM is going to be equal to 110 degrees. And again, notice how I'm doing very little work with this. That's because I know my properties of my parallelograms. And so KLM is an opposite angle of KJM. And since they're opposite and I know my properties, I know they are congruent to one another. So that's why they're 110. And then finally, JKL. Okay, that's this whole angle here. Just like before, we know that these are opposite angles. It's opposite from angle JML. And if JML is equal to 70 degrees, which we said earlier, we know now that JKL is also equal to 70 degrees. And that's pretty much it. That's all you have to do for this section. All it is really is just applying your properties of parallelograms. So you got to memorize those 6 properties and you will be good to go. Have a good evening.